Next, we have to measure the densities of various objects. You can determine the density of regular shaped solid object, irregular shaped solid object by using the displacement method, and the density of liquid. In all of these cases, you have to use the same formula of the density, which is mass per unit volume. Either you are calculating the density of the regular shaped solid object, or it's the liquid, or it's irregular shaped solid object. In all of these cases, you have to use the same formula for the density. So first of all, let's calculate the density of regular shaped solid object. For that, actually you need to find out the volume and the mass. First of all, if I consider any regular shaped solid object just like a cube, then how you can find out the density of that cube? So you have to follow the following steps in order to find out the density of the cube. You know very well that density is equals to mass per unit volume. From here, you can see, first of all, you need to calculate the mass. And the second thing that you need to know is volume. You have to calculate both of these in order to find out the density. So how you can find out the volume and the mass? The volume is just calculated by using the same formula that I already tell you for the cube. Just multiply the side length 3 times. I can simply say that for any regular shaped solid object, you need to find out the dimension of that object, such as width, height, length or radius. All of these you can calculate with the help of ruler. After that, use the formula for the volume of that regular shaped solid object. Put here values, you get the volume of that object. Just like in the case of cube, when I have to find out the volume, I suppose that the side length is 0.2 meter. Then what is the formula for the volume? V is equals to d cube. Just multiply 0.23 times, you get the volume. So it would be 0.008 meter cube. This would be the volume in this case. After that, you also have to find out the mass of that object. The mass is measured with the help of digital balance. You need to place that object on a digital balance. From here, you can find out the mass easily. You can see here the digital balance is given. You need to place the object here on that digital balance, and you can directly see the mass of that because here the mass is calibrated in digits. After that, you repeat this experiment again and again, and at the end take the average of the result. Then use the formula of density, which is mass per unit volume. You can easily calculate the density of the object. So, in short, I can simply say that when you have to find out the density of the regular shaped solid object, first of all, you need to calculate the volume, which you can easily calculate by measuring the dimension of that object. And then use the formula of the volume to find out the volume of that object. Secondly, you have to find out the mass of that object by placing it on digital balance. And the third step is that repeat this experiment again and again and take the average of the result. Then use the formula of the density to find out the density of that object. The same is given here. Measure the dimensions of an object such as its width, height, length and radius with the help of ruler. After that, using the formula, determine the volume of that object. Second step is that measure the mass of the object by placing it on digital balance. Repeat the experiment many times and take the average of the result. By using the formula of the density, determine the density of the object. So in this way, you can easily calculate the density of regular shaped solid object. Next, we will calculate the density of irregular shaped solid object by using the displacement method. You already learned about the displacement method, which is used to calculate the volume in the topic 1. So first of all, which steps you need to follow when you are going to find out the density of irregular shaped solid object? Just consider that irregular shape, which is the stone. You are going to find out the density of the stone. First of all, again use the formula of the density, which is mass per unit volume. You need to find out two parameters, which is mass and volume. You can easily find out the mass of any object by placing it on the digital balance. Digital balance is given here. Just you need to put the object here. You can find out the mass by these digits. After that, you have to find out the volume of that object. For that, you actually have to use the displacement method. In this method, you need to fill the Eureka can with half of the water, that is up to the spots level. After that, also put the empty measuring cylinder beneath the spot. And then you need to place the object into the Eureka can carefully. You see that the water start displacing. And some of the water will enter into the measuring cylinder. Then by that water, you can easily find out the volume of that object. When you find out the volume of that object, you already know the mass of that object. You have to repeat this experiment again and again and take the average of the result. At the end, you have to use the formula of the density, which is mass per unit volume, to find out the density of the object. Here again, in the short, I can simply say, first of all, find out the mass by placing it on digital balance, and find out the volume by displacement method. When you find out both of these parameters, repeat the experiment again and again and take the average of the result. At the end, use the formula of the density to find out the density of the object. So it's given here, measure the mass of the object by placing it on digital balance. You have to place the object on the digital balance and find out its mass. Fill the Eureka can halfway with water just below the spot. Put the empty measuring cylinder beneath the spot. Lower the object into the Eureka can carefully. Note the reading of the measuring cylinder, which will be the volume of the displaced water. Repeat the experiment many times and take the average of the result. By using the formula of density, which is mass per unit volume, you can easily find out the density of the object. Here you can see the diagram. It's basically used to measure the volume so that we can find out the density. It's basically the displacement method. Here you can see there is a Eureka can. That is filled up to the spots level. There is also the measuring cylinder placed just beneath the spot, and when you lower the object into the can, then the water actually moves from that can into the measuring cylinder. Here is calibration on the measuring cylinder. You can see 120, 100, 75, 50, 25. So you can easily find out the volume by the calibration of the measuring cylinder. When you find out the volume, you already know the mass. So you can find out the density by using the same formula. After that, you want to find out the density of the liquid. How you can find it? Again, when you have to find out the density, you know that it's mass per unit volume. You need to know the mass of the liquid plus the volume of that liquid. So mass of the liquid is simply determined by placing it on a digital balance. Next, you need to calculate the volume of that liquid. You need to place the water in a measuring cylinder and you can easily calculate the volume from here. After that, when you put some water into the measuring cylinder, you also need to take the new reading by placing it on the digital balance. Because in this case, the mass will change when you put some water into the measuring cylinder. Then repeat this experiment again and again and take the average of the result. The mass of the liquid can be determined by subtracting the final reading. Final reading is basically the mass of the measuring cylinder plus water or any liquid from the initial reading of the measuring cylinder. The initial reading is just the empty measuring cylinder. So the formula is given here. Mass of liquid is equals to mass of cylinder that is filled with the water minus the mass of the cylinder. You actually calculate the mass of the liquid. You see here the mass of liquid plus cylinder. It is basically equals to the mass of cylinder plus mass of liquid. So when you have to find out the mass of liquid, it would be equals to the mass of liquid plus cylinder, means their combined mass, minus the mass of cylinder. You actually have to find out the mass of the liquid. It means that when you place the measuring cylinder on the digital balance, first take the initial reading, after that put some liquid in it and also place it on a digital balance. Take the new reading, it would be the final reading. Subtract both of these readings to find out the mass of the liquid. Then you have to use the same formula, density is equals to mass per unit volume. You can easily find out the density of the object. Here how you can find out the mass so that you can calculate the density. First of all, in the first figure you can see there is no water, it's just the empty measuring cylinder. When it is placed over our digital balance, then you need to take the reading of the balance. Here it is shown 30 gram. After that, when you put some liquid into the measuring cylinder, the reading comes to be 110 gram. So you just need to subtract 110 minus 30, you get 80 gram. So 80 gram is basically the mass of the liquid. You can easily find out the mass of liquid by subtracting the mass of liquid plus cylinder and the mass of the empty cylinder. And you also know the volume by this calibration of the measuring cylinder. You can use the formula of the density to find out the density of that liquid. Here is the exam question that appeared in October-November 2020. A metal ball is attached to the cork and it is lowered into the measuring cylinder, pulling the cork into the water as shown. So you can see here a diagram. In the first diagram, there is a ball and cork above the water. Both of these are above the water. These are not dipped into the water. Then ball is fully submerged but the cork above the water. In the second figure, the cork is not dipped in the water but the ball is fully dipped in the water. In the last one figure, you can see here both the cork and the ball, these are submerged in the water. The mass of the cork is given, which is 4.8 gram. What is the density of the cork? You need to find out the density of that cork. Option A, 0.15 gram per cubic centimeter. B, 0.20 gram per cubic centimeter. C, 0.60 gram per cubic centimeter. D, 5.0 gram per cubic centimeter. So how you can find out the density of the cork? You have to use the same formula. Density is equals to mass per unit volume. The mass of the cork is given, which is 4.8 gram. You also need to find out the volume of the cork. In the first figure, you can see here the volume of the water is given, which is 48 cubic centimeter. In the second figure, the volume is given 56 cubic centimeter. It is the combined volume of the water plus ball. In the last figure, the total volume is 80 cubic centimeter, which is the volume of water plus ball plus cork. because the ball and cork, no, both of these are submerged in the water. So you can easily find out the volume of the cork by this data. Let's see the answer and explanation. So first of all, the mass of the cork is given, which is 4.8 gram. The volume of the water, which is from the figure 1, is 48 cubic centimeter. The volume of water, ball and cork, it's 80 cubic centimeter, is taken from the last figure, and the volume of water and ball is 56 cubic centimeter. You need to find out the volume of the cork. See, by this equation, which is the volume of the water, ball and cork. It is basically equals to the volume of water and ball plus the volume of cork. You can easily find out the volume of cork from here. The combined volume of water, ball and cork is given, which is 80 cubic centimeter, minus the volume of water and ball is given, which is 56 cubic centimeter. So put here 56, you get the volume of the cork, which comes to be 24 cubic centimeter. After that, use the formula of the density. Density is equals to mass per unit volume. The mass is given 4.8 gram and the volume is 24 cubic centimeter. You get the density that comes to be 0.2 gram per cubic centimeter. It means that answer B is correct, because in the second option the density is given, which is 0.2 gram per cubic centimeter.